Hi, my name is Tom Riley, and I'm working with Megan Rush, KATHRYN Stewart, and Peter Coles. And today we're going to be talking to you about pulleys and relative motion. So we're going to be demonstrating the physical concept with this model. Right now we have set up a two-pulley system. So there's one pulley, two pulleys. And we're going to show how when we pull here, the relative position of this point here and the weight on the second pulley, and also the relative velocity of this point here and the weight. And then we're going to relate it to the physical equations that you're going to be using when you do your homework. So we're going to start with the two-pulley system, the position equation, and then the velocity equation. And then we're going to set up a four-pulley system, so we're going to have two more pulleys, and we're going to relate it with these two equations, position and velocity.
Hello, my name is Peter Coles, and I'll be covering our equations for the two-pulley system. As you notice, we have the length A plus 2 length B equals length total. In our system, as you saw before, there was two strings attached to the one pulley on our weight, and then one string that we were pulling. This is the string that we are pulling, and here's the two lengths which are equal, which are attached to our weight. So adding those together gives us our total length for the entire system. And then when you take the derivative of that, you get the velocities. However, the length for our total system does not change at all. This isn't stretchy string, it's ideal physics string, so it doesn't move at all. Therefore, meaning this velocity is actually going to equal 0.
I'm KATHRYN Stewart, and I'm going to be covering the demonstration of the concept that you just learned in equation form. Currently, my finger here is at 2, and the bottom of the weight is at 2 as well. When I move my finger down to the 10, the weight moves up to the 7, which is half the distance that I moved to this one.
Hi, my name is Megan Rush, and I'll be showing y'all our demonstration for the velocity equation you saw earlier for the two-pulley system. So we have our two-pulley system set up with Peter pulling one end of the string while the other side has the weight rising. So what will happen, well, Peter would be pulling about 2 inches a second on his side of the string, and we'll be recording how fast the weight on this side rises up. So over here on this table, we have written down what just happened, basically. So we have our time from 0 to, it took about 6 seconds for him to go the full length of the measurement, which was 12 inches. And so we have the position of the weight at every second. And as you can see, the weight actually rose 1 inch per second. So, which is about half the speed of the other side of the string. So next we have our four-pulley system set up. We have our string attached here at this point. We have 2 pulleys at the top and 2 down at the lower end. Our 2 weights here are taped together to mimic an ideal single weight together, so that when we pull on the end of this string, it will work. Rise as 1.
Okay, once again, we're going to cover the equations of motion. As you noticed, when we actually looked at our device, you had the length of the string you're pulling, and then since we had 4 pulleys, there's actually 4 strings that were of equal length that rise as 1 when the weights move up. So the simple equation, length A plus 4 length B equals the length total. Once again, you take the derivative of that, so you get the velocity plus 4 of the velocity of B equals the velocity total, which once again equals 0, because even though we switched to 4 pulleys, the total length of our string is not changing at all.
I'm demonstrating the four-pulley system. So we're looking at the unchanging length of the system, which means that once I pull this down 12 inches, the weights, which are connected together so that they rise in unison as one weight, rise 3 inches.
Okay, so now we're going to be demonstrating relative velocity for the four-pulley system. So Peter here is going to move his finger at about 2 inches per second. So then we're going to watch the speed of the weights and see how far they move in the same amount of time that Peter moves his finger. Okay, so the weights moved from 0 to 3 inches, and Peter moved his finger from 0 to 12 inches. So that means that it's moving at a quarter of the speed, or about 0.5 inches per second. Okay, so here's the values that we recorded from that last demonstration. So here's the time from 0 to 6 seconds, and here's the position of the weights. So they started at 0 inches, and then they moved a total of 3 inches in the 6 seconds. So that would mean that they moved at a velocity of 0.5 inches per second, as compared to 2 inches per second of the finger in the string. So that concludes our demonstration of the pulleys and relative motion. Thank you.